Bienvenidos a Mazatlan. Welcome to Mazatlan.
This city is about the same size as Salt Lake, but a world of difference. Hi, I'm Patty Sherman.
And I'm Rick Romero, and tonight we're going to take you right down into it.
Also tonight on PM Magazine Utah, we'll discover the glamorous world of international Grand Prix racing and find out the amazing contributions Utah is making to this sport.
Then we'll meet a woman who predicts earthquakes. She hears disasters before they strike, and we'll get a prediction of the next big quake.
Jim Montgomery meets Mr. T, the hot star of the A-Team.
And Julie Kessel has all the latest on what's going on this weekend.
It's really dangerous. Those rocks are close together.
We're right on the coastline of Mazatlan, but you'd think we were in Acapulco when you see cliff divers going into these treacherous waters.
It's definitely something you would not see in Utah.
No, but there is a spot in Utah that has some dangerous activity connections, and that's Magna, Utah. What? Well, it's Grand Prix racing. What's their connection? Well, you'll find out just right now.
Grand Prix racing is the most glamorous, most expensive, and most technically sophisticated sport in the world. It's also the most dangerous.
Got 2 wheels off the road onto the dirt. The car then started to spin and it went off backwards, hit a metal Armco barrier backwards, I suppose 120 miles an hour.
Veteran driver John Watson is alive today because of a remarkable space-age race car chassis made in Magna, Utah by the Aerospace Division of Hercules Incorporated.
I got out of the car, walked away back to the pits, explained what happened, and left to go home.
That black box John's standing next to was made by Hercules. It's the chassis of his race car, the one he crashed. It's been cleaned up but not repaired. It didn't need it.
I was very happy to be able to walk away from what was certainly a very spectacular accident.
John Watson's from Ireland, and he drives for the McLaren racing team. They've faced a real challenge. Some of the other teams are using turbocharged engines, which get 50% more power than the McLaren.
We've got to make up that difference in superior handling, and it's quite difficult to do.
That's what's brought a British race team to a Magna, Utah aerospace company. The question was, could Hercules use missile and satellite technology to make faster and safer race cars? The answer was a chassis made from something called graphite fiber. Strangely enough, it starts out no stronger than a piece of aluminum foil from your kitchen. In a revolutionary new process, the fiber sheets are stuck on a mold. Then a giant plastic bag is sealed around the mold. The air is sucked out, and the whole thing is baked in an oven at 350 degrees, just like a giant turkey. The result is a freshly baked Grand Prix winning race car chassis. But how do they get the mold out?
That's a secret.
As senior project engineer for Hercules, Rob Michael isn't going to give away any company secrets, but he loves to explain graphite's advantages over aluminum and steel.
This is steel brick, and it weighs about 32 pounds. If we use this as a baseline, we'd say that the aluminum brick here is about 11 pounds, and it's not as strong as steel and not as stiff. Then we go to the graphite. It weighs about 6.5 pounds. It could be designed as high as 2.5 times the strength of steel.
The McLaren team got their first Hercules chassis about 2 years ago.
Carbon fiber car for the first time, of course, it was totally different because, first of all, it's much more rigid.
John's teammate is a two-time world champion driver from Austria, Niki Lauda.
Because I really believe that this monocoque is the strongest, because the cars today are so quick around corners, and all the bodywork you see on the cars, which makes them look quite wide, is only fiberglass, so it doesn't really protect you at all.
Niki was horribly scarred when his car crashed and burned in 1976. He retired from racing for 2 years. He only returned because of the safety of the Hercules-made chassis.
The reason I really chosen the McLaren deal is because I really believe that this monocoque is the strongest. So I really believe in the material we use.
And the people at Hercules really believe in John and Nicky.
Don't wear fade, we don't mind looking like this.
The real test of the graphite fiber chassis takes place at Grand Prix races all over the world. 2 years ago, Watson beat the more powerful turbos once with the brand new chassis. Last year, Watson and Lotto won 4 races, and they nearly won both the drivers and the team championships. More importantly, despite at least 4 major crashes at speeds up to 160 miles an hour, there was only one slight driver injury.
I hit the wall once in Hockenheim with a German race in practice, unfortunately. It hurt my wrist and couldn't make the race, but the car had no damage at all. So the car is actually stronger than the driver was at that time.
Back in Magny, Utah, Rob Michael and his team believe that graphite fiber will improve the safety and performance of some of the trucks and cars you'll be driving on the streets in the next few years.
Detroit's going through a phase now of developing new processes for working with fiberglass and graphite. And they're coming up with some fairly low-cost compression molding type things where you just lay the material in, close the mold, pop it out, and you can crank one out a minute.
And John Watson and the McLaren team are looking toward the future too, with the strongest, safest chassis in Grand Prix racing.
To do the job so well, it's like a high. It's just something that you rarely experience.
Well, since we finished that story, the 1983 Grand Prix season has started. And out of 3 races, the McLaren team has already won 1. And in the team championship, they're leading. Well, it looks like graphite fiber is definitely a material for the future.